Good morning, everyone. This is Shanti. Now, I am explaining the traveling salesman problem. Traveling salesman problem is just a problem, and we can find the cost and time and distance. Less cost and less time and distance. For example, in traveling salesman problem, there are a number of cities a salesman must visit. That is 1, 2, 3, 4, and A, B, C, D. We can visit the given. The distance of time cost between every pair of cities is given. For example, in traveling salesman problem, in a question, the time, distance, or any cost is given by the problem. The salesman and the conditions for the salesman is the salesman must traveling from the salesman must traveling from he visit every city and with less time and less cost. This is the conditions for the traveling salesman problem. The salesman starts from his home and he must visit every city exactly once and return his home city. The problem is to find the route of shortest distance and time and cost. By the using of traveling salesman problem, you can find the distance or time or cost. In traveling salesman problem can be solved, if I know that the traveling salesman problem can be solved with only two ways. I know by this way, and this is a dynamic method and branch and bound method. So consider we can take an example with the numeric digits, that is 1, 2, and 3 and 4. 1, 2, and 3 and 4. So this the diagram shows that if 1 can travels from 2 and 2 can travels from 3, 3 can travels from 4 and 4 can travels from 1, and also 2 can travels to 1, and its ways 3 can travels to 2 and 4 can travels to 3 and 4 can travels to 2 and 3 can travels to 1. This is the adjoint side, so it can travel any way. This is called travel salesman problem. Consider we taken an example of 0, 10, 15, 20, 5, 0, 9, 10, 6, 13, 0, 12, 8, 8, 9, 0. And this matrix contains 4 columns and 4 rows. This matrix contains 4 columns and 4 rows. So we can take in the example of 1 to 2, and we can also read them into 1 to 2 or 2 to 3 or 2 to 4, 2 to 5, and given matrix is considered with naming with A. A is equal to the given matrix that it has 4 rows and 4 columns. And we can also take an example of we can also taking an example with 1, and it has two nodes, that is 2, 3 and 4. So it has number of 3 possible outcomes. So it has number of 3 possible outcomes. Then it is so it and two adjacent sides is 3 and 4. So it can travels from 2 can travels from 2 or 3 and 1. So this is a possible ways of 2 and 3 and 4 and 3. And also and 3 possible way is 2 and 4 and 1 and 2. And 3 possible way is 3, 2, 4, 1 and 2. And we have so we can take in, and this is the terms of, and it is connected, so the traveler salesman can travel to 1 by this way. This is the dotted indication, that is the traveler salesman been connected. So 4. and the 4 is connected to 2 and 4 is connected to 3. So the 2 is connected to 3 or 3 is connected to 2. So if the 2 and 3 is connected to, so the 2 and 3 and 2 is connected to the 1 of the travel salesman program. So we can take in by this fill method. So we can observe the tracing of every element. So you can observe the tracing of every element. So we can take in from, and this is the 1, and we can apply that this is 1. We can assume that we taken as 1, then 1 to 4, and this is, and from above picture we notice that and from the above picture we notice that 1 to 4, 4 to 1 it considered as 4 to 1 it considered as 8. So we can write 8, and also we can assume that 1, so it is 3 to 1. So the travel salesman can travel from 3 to 1, then it is 6. 4 to 1, then it is 8, then we can write it as 8, then it is 1. 2 to 1, then it is written as 5, so we can write it as 5, then it is 3 to 1, then it is written as 6. 6 is the traveling salesman problem, and it is 1, and 1 to 2 to 1, and it is 5. This is the traveling salesman problem, and we have so much of cost, and so it can be travel, and it's 868 and 565, and this is the minimum cost of the traveling salesman problem. And also that, and from the above also we can assume that the link from 4 to 8, from the 4 to from 4 to 3, then its number is 3 to 4, then its number is 6, so we can write as 6 plus, and from 1 to 4, so we can add it by two numbers, then it is 12 plus 8 is equal to 20, and by the given number also, for the given root of values also, from 3 to 4 the value, 3 to 4 the value is 12. 4 to 3, 4 to 3 the value is 9, then plus 9 plus, and the remaining travelings is 6, then is 15. From 4 to 2, from 4 to 2, 4 to 2 the value is 8, the value is 10 plus the remaining is 8, and also from 2 to 4, 2 to 4 the value, 4 to 2 the value is 8 plus 8 plus 5 is equal to 13, then from 3 to 2, then from 3 to 2 is 2 to 3 is 9, and from 3 to 6, and from the given is 6, then it is 15, then it is 15, so we can assume that the given from, and from 2 to 3, and from 2 to 3 to 2, then it's 13 plus 5, then it's 8, so we can assume, so we can write by this form on the circle, that's, so we can also write them, and from the given example we can write in the above form. So write in the above form, from 2 3 to 2, from 3 to 2 it is from 2 to 3 is 9, and the given is 20, so we can plus 9 plus 20, 9 plus 20 is 29, or and it's, and also from 2 to 4, 2 to 4 is 10, 10 plus 15, 10 plus 15 is 25, so and the lowest number is 25, so we can take in the least count is 25, and least count is 25, and also from 2 to 3 the number is 13, so and also the least count is 18, so 13 plus 18 is 21, and from 4 to 3 the value is 13, and the 12 plus 13 is 25. So so we can take in the least count as 25. And also from 2 to 4, then it's taken as number of 8 plus 5, 8 plus 15, then it is 8 plus 15. Or from 3 to 2, the value is 9 plus 18, so the value is 23. So we can take in the lower value, so we can take in the 23. From so we can also find the root of under root or any cos of 1, and the adjacent sides of the 1 is they have chances of 1, 2 and 3 and 4. So we can write as 1, 2 and 3 and 4. So we can must fill up the from 2 to 1. From 2 to 1 is a 5. From 1 to 2 is a 10. So it is a 1 to 10. So 1 to 10. And also from 1 to 3 it is a 15. And also from 1 to 4 it is a 20. So we can plus the remaining numbers also. We can get 35 as 35 is the least number of the point. And next we can conclude that, and next we can also writing the traveling salesman problem as g of 1 comma 2 comma 3 and 4, and this is the formula of mean of c of 1k plus g of k comma 2 comma 3 and minus of k. And general formula for the travel salesman problem is g of I comma s and mean of e of s k e of s of c of I comma k plus j of k comma s minus k. From g of 2 comma 4, from g of 2 comma 5, from g of 2 comma from g of 2 comma 5, from the formula we can notice that 5. And from 3 of 4, from this formula then it gets 6. And g of 4 comma 4, then from this formula we get 8. And g of 2 comma of 15, this form of 15. And g of 2 comma 4, that gets 8. And g of 3 comma 2 we gets 5. And g of 3 comma 4 gets 8. G of 4 comma 2 we gets 5. And g of 4 comma 3 and we get 6. G of 2 comma, and we can consider the second line, then we get two forms, g of 2 comma 3 comma 4, then it gets 25. And g of 3 comma 2 comma 4, then it's 25. G of 4 comma 2 comma 3 is 23. The last value of remaining is, and the last value of remaining is g of 1 of 2 comma 3 comma 4, then mean of c of 12 plus g of 2 comma and 3 comma 4, and c of 13 plus g of 3 comma 2 comma 4 plus c of 14 plus g of 4 comma 3. And this is the exactly value of 1, g of 2 comma 3 comma 4. So we can write in the traveling salesman problem, and this is value is and this value is 35, and this value is 35. So we can find the traveling salesman problem by this method. Some important points of traveling salesman problem is the traveling salesman problem TSP is an algorithm problem tasked with finding the shortest route between a set of points and location that must be visited. Important of traveling salesman problem is because the problem is one of the general optimization, its solution has applications for diverse fields including transportation, electronics and genetics. For TSP, traveling salesman problem relatively efficient for a small number of nodes TSP can be solved by executive search for a large number of nodes. TSPs and very captionally difficult to solve exponential time to conversions can be used in and traveling salesman problems are also used in dynamic application and also used in computer programming languages and adapts to change such new distances and from because the problem is one of the general optimization. Disadvantages of traveling salesman problem and disadvantages of traveling salesman problem is and it's requires so much of time to solve this problem, encourage high pressure selling and remain uncertain about income, attract salesmen by applying wrong business practices, difficult to understand and operate, sales may fall in spite for very best effects. And for traveling salesman problem, it has so much, it taken so much of time to produce the traveling salesman problem and the algorithm for dynamic approach for the traveling salesman problem is s and in s its starting point and is a subset of input cities and distance among the cities and cost of tsp result and cost produced by western and cost is this is the algorithm for and this is the algorithm for traveling salesman problem and conclusion of the traveling salesman problem is conclusion of the traveling salesman problem is the salesman goal is to keep both travel cost and the distance traveled low as possible. The salesman just assume that the cost of the travel salesman it can be decreased and also the distance also can be decreased. And thank you friends for listening my assignment. So thank you to all.